How's it going, ladies and gentlemen? Mr. Donahue here again, this time taking a look at how to determine the limiting reactant. Basically, how many hamburgers can you really make if you only have 5 buns? Doesn't matter how many hamburger patties you got. If you only have 5 buns, you're only making 5 burgers. All right, so our objectives will be to identify which reactant is the limiting reactant, which will determine how much product can be made. So what is a limiting reactant? Well, let me give you an analogy. Let's say you're at a barbecue and you're barbecuing for your friends and you had 12 beef patties. You got a dozen beef patties, but you only have 5 buns. How many hamburgers could you actually make? Well, you can only make 5, right? Because you run out of buns then. The buns are your limiting reactant because you only got 5 buns. You got extra everything else, but your buns are what you run out of. Why? Because you don't have any more hamburger buns. Buns would be your limiting reactant. All right, cool. So the substance that gets completely consumed during a chemical reaction is a limiting reactant. It's the thing that you run out of. All of it gets used up. This is going to determine how much product you can make because you ran out of this stuff. That stopped you from making more. If you had more buns, you could have made more burgers. So here's like a visual representation. So let's say I had this reaction, and it's saying if I had 1 carbon and 1 O2, I can get 1 carbon dioxide. And this was my setup. I had 3 carbons, and I have 4 O2s. Well, which one's my limiting reactant? Well, let's think about this. What's going to happen? Let's see. I have a 1-to-1 ratio of these things, and I have 3 carbons, right, for a carbon to oxygen ratio, which means I can make a max from those carbons 3 CO2s. Awesome. Let's see what happens, right? Whoa, those 3 carbons each take an O2, and 1 O2 gets left behind. It's left over. So the limiting reactant here, what did we run out of? Carbon. Carbon was our limiting reactant because we ran out of it. We used up all the carbon. We had excess O2. We had extra O2, so the limiting reactant was carbon. Now, the limiting reactant isn't always which one you have more of, because let's take a look at this example. I need 1 Pb, and I need 2 chloride ions for each lead ion to give me 1 PbCl2. So if I'm looking at this setup, well, I got 3 lead atoms, or 3 lead ions, and I have 4 chloride ions. Now, I have more chloride ions, but that doesn't mean it can't be our limiting reactant because we need twice as many chloride ions as we do lead ions. So let's see what happens. All right, so we have the reaction go, boom. We used up all of the chlorine, and we have an extra lead. So this one is excess, which means what was our limiting reactant? The chloride ion, right? So these visual representations are nice because we can see everything, but are we going to do that for every single kind of chemistry problem? No, we're going to use math instead, all right? So let's take a look at another scenario. It says 27 grams of nitrogen is reacted with 15.5 grams of hydrogen to make NH3. What is the limiting reactant? So how do we even go about solving this? Well, first thing that we're going to do is we're going to circle and box the compounds of interest. This is a little trick that I do, and I highly recommend everybody do it. So we got nitrogen, and that's the grams of nitrogen. So I'm going to circle everything nitrogen, and I'm going to put boxes around everything that's hydrogen, right? Boom. All right, so I've done that, and now it says convert the grams of each thing into moles. So how do I do that? Well, I got to use the GFM. And what I usually do too is like I'll put grams, I'll use the actual equation here. So let me free up some room here and do my boxing and circling a little bit smaller. So I'll go, all right, I got 15.5 grams of hydrogen. So I'm going to put that up top, 15.5 grams. And nitrogen, I got 27.0 grams. And now I'm going to convert that into moles. So I got to look up and figure out N2's gram formula mass, which is going to be that 28.02 because it's 2 nitrogens. So it's saying I really got 0.9636 moles of N2. And I do the same thing for H2. Its GFM is going to be that 2.02. So I divide 15.5 by 2.02, and I get 7.67 moles of H2, right? So now I got how many moles of each thing that I'm starting with instead of grams. Now I need to create a mole ratio from the coefficients in the balanced chemical equation. And it's important that it is balanced. Sometimes they'll give you a chemical equation that needs to be balanced because they want to like double test you. Do you know how to balance and then do this stuff? This one is balanced already, so we don't have to worry about that. Well, my N2 to H2 ratio is going to be 1 to 3, right? Because the coefficient in front of N2 is 1 in front of H2 is 3. So now we got to choose one of the substances, either, whatever it is, substance X, and apply it to the mole ratio, and look at how much of the other one, substance Y, we would need. So if you have more substance Y than you need, then X is the limiting reactant, because it's saying you have extra Y, you've run out of X. If you use up all of the X, there would be no Y left over. There would still be Y left over. If you have extra Y, you use up all the X. And then vice versa. If you need more substance Y than you have, then Y is the limiting reactant. Like, let's say you needed 100 moles and you only had 50 moles. Well, then you've run out of that stuff. You don't have enough. That's your limiting reactant. So let me finish it for this problem. So, okay, just pick one. It doesn't matter. I'm going to use nitrogen because why not? So 0.963 is to X. How much X would I need? Well, X will equal, I wrote it down, beep, bop, boop, 2.891 moles of H2. Now I have 7.67 moles of H2, which tells me I have extra H2, right? So extra H2 means that I've run out of N2. So my limiting reactant would be N2 because I have extra H2. I only need 2.891 moles, and I have more than that. I have 7.67 moles. All right, so let's take a look. New example. Given the reaction Zn plus copper chloride gives me zinc chloride and copper, in an experiment, 7 grams of zinc is reacted with 8 grams of copper chloride. What is the limiting reactant? Okay. First things first is convert the grams into moles. So for zinc, I got to do 7.00 grams divided by the formula mass of zinc, which is 65.38 grams per mole, which gives me, bop, beep, bop, boop. I wrote it down, I promise, 0.107 moles of zinc. All right, so next thing is I got to do the copper chloride, right? So CuCl2. I have 8 grams of that, 8.00 grams divided by the formula mass, which is going to be the mass of copper, which is, I look it up, 63.55, plus 2 times the mass of each chlorine. And each chlorine is 35.45 grams per mole. And I do that, and this becomes, I wrote it down, 134.45 grams per mole. So it's really saying 8 divided by 134.45, and that gives me 0.0595 moles of that copper chloride. So now I set up my mole ratio. In this case, it's just 1:1 for zinc to copper chloride. So I go, all right, just pick one of them. All right, well, I'll use zinc. So we get 0.107 is to X. This one's really easy. X is I would need 0.107 copper chloride moles to react completely. I don't have that much, so that tells me that I'm running out of copper chloride. I need 0.107. I only have 0.0595. So my copper chloride is my limiting reactant. All right? So going back to this one. All right, starting fresh. It says 27 grams of nitrogen is reacted with 15 grams of hydrogen to make NH3. What is the limiting reactant? All right, so first things first, convert the grams into moles. So I got 27.0 grams converted to moles. And I get an answer of 0.9636 moles. And I do the same thing for hydrogen, and it says I have 15.5 grams, and I divide it by its GFM of 2.02. And then I get total moles of 7.67 moles. And all right, well, what is the limiting reactant? Well, let me set up my ratio. I got N2 to H2 as a 1:3 ratio. And why don't I start with N2? So my N2 is that 9636 is to X, which tells me that my X is going to have to be at 2.891. So that's how many moles of H2 we need to react with all of that nitrogen. We have 7.67, which means we have extra H2, which means we run out of N2. So our limiting reactant would be N2. All right, so yeah, what's meant by the term limiting reactant? Summarize, how do you determine which reactant is a limiting one? That's what you need to be able to do. All right, hope you found that helpful. I'll see you in class. Bring questions. This one gets eyebrows.